This is the second video for the 428 lesson. I would encourage that you try some of these on your own and then maybe just check them with my graphs. Or if you feel like you need to see a couple more examples, then by all means do them with me. We only have 3 more problems. Number 5, we have those either loved or dreaded lines where there's only one variable, also known as vertical and horizontal lines. So we have a line at x is greater than or equal to 4, which is x-axis is horizontal, but this is vertical. It is solid. And I don't have the best straight edge, so I'm going to try to just hand draw this in. There we go. And then we have a horizontal line at -3, and this one is also solid. And x is greater than or equal to 4 means we're going to shade to the right because we need x values that are greater than 4. And we want y values that are greater than -3, which is above the red line, which means that the feasible region or the solution set is anything in here. Anything on the boundary lines as long as it's touching the feasible region. And in this case, finally, we get that the point of intersection works as well. Number 6, back to some non-vertical horizontal lines. If you're ready to try this one on your own, you can pause the video. And if I went too fast for number 5, feel free to pause it or rewind it. Let's isolate the first one. We have a y-intercept at -2 and a slope of 1. This one is solid. And we will be shading this one below, so the bottom half. But before we do that, let's do the other one. And we have y. We had to flip the inequality sign because we divided by -2. Y is less than -x minus 3/2. We're going to need to do some estimating with this. So this one is at -1.5. And we're going to go down 1, right 1. And this one is dashed. And this one's also below. So we'll be shading right in that part. So we can pick things on the black boundary line as long as they're touching the yellow feasible region. We cannot pick things on the blue dashed boundary line, and that means that we also can't include the point of intersection because both boundary lines need to be solid. Number 7, we have 3 linear inequalities. First one, let's rewrite this one. And this one's dashed. All right, next up. This one's also dashed. And last we have a vertical line that is dashed and on the y-axis. All right, and let's see where our feasible region is. It says for the blue line, we are going to shade below, which would be this portion. For the black one, we're going to shade above. And for the green one, we're going to shade to the left. So if you're wanting to do the partial shading, feel free, but it ends up being this middle triangle. Didn't have to be there, but it is kind of cool that we get that. Could have been some of the other ones. All right, let's label our boundary lines. This was x is less than 0. This one was y is less than 2x plus 5. And this was y is greater than negative x minus 1. And we're going to find actually the area of the feasible region, which is a triangle. And we can sketch it if that's helpful. But area formula for triangle is 1/2 base times height. And we need to use vertical and horizontal sides for this to make this a little bit easier. So 1, 2, 3, 4, 5, 6. And 1, 2 is this right here. All right, so we have a base that's 6 and a height that's 2. 1/2 of 12 is 6 square units. So it has an area of 6 square units.